music theory, modal ranges and modal half steps are objectively better than the traditional scale degree system currently in use today, which leads to the logical conclusion that the traditional scale degree system currently in use, by the way, by comparison, is stupid. How dare you? Okay, wait, let me lay out the argument here. And just remember, I highly recommend that if you have any questions about anything that I lay out, that you actually just copy the transcript, paste it into your favorite AI, such as a ChatGPT or a Perplexity. Those things are great at being able to look at a completely logical system, such as what music is, and basically break it down and give you the arguments, give you the pros and cons. So what is the objective? Introduce a more efficient system for understanding and visualizing modes on instruments, especially the guitar. So in other words, what I want to be able to do is help people to map out the fretboard or whatever instrument they have, because these concepts do apply even to the piano. I say even the piano because, once again, of course, we guitarists get a little bit jealous of the piano because it looks like music theory was basically created with a piano at hand instead of a guitar in hand. But that often leads to problems, as we've seen in the past, with piano players because of the way you start to learn things in terms of one scale first before looking at the scale pattern as a whole. So this does apply to other instruments as well. So I want to basically remove the roadblocks which are being put in place by some of the terminology, in particular terminology that has to do with measurements. So that's what we'll get into. What's the core argument? Modal ranges and modal half steps offer a cleaner, logically consistent framework for theory and application. So what I'm talking about here is the measurement of distance. Distance becomes important because that's how we're going to basically measure our chords. And the chord naming convention as well as the distance naming conventions are not optimally what you would think someone would put together if they had all of the tools on the table today and putting it together without having to take into consideration, the history and following the same trajectory as we learned things throughout history. So as we look at this, let me give an analogy, and I want to just keep this analogy in mind, and we'll see how it applies to the current system. Let's imagine that we have a location of our home, a location of a school, and a location of a friend's house. And this is our system. This is our three locations that we are going to be traveling between. And one day, let's imagine that we go from our home and then we go to the school, maybe to drop off the kids, and then we go to our friend's house, for example. So if that is our system, then we might lay out the directions. We might say, hey, look, how do I get to the school? What's the direction of it? What's the direction to get there? Is there more than one way to get there? Maybe I go around the block. Maybe if I go around the block this way, or I go around the block this way. There's two ways I can get there if it's a circular pattern and I'm going around a block or something like that. So how do I get from my home to the school? How do I get from the school then to my friend's house? And then I can imagine, how can I get from my friend's house back home? And so those are the three map quests that I might map out. In terms of distance, we can say, okay, the home to the school, let's say, is 7 miles. The school to the friend's house is 5 miles, and the friend's house back home around the circle within the system is going to be the 3 miles. So that's what we have here. Now we might say that what if the next day I don't start from home because I spent the night at my friend's house? So instead of being here, we're over here in the system, and then we go home, and then we go to the school. So now we were here, we went home, we went to the school. Question: when we went from home to school, do I have to make a separate map quest? Do I have to map it out and say, give me another map? Things have changed. And of course, if you say yes, you need to map out a new map quest than you did yesterday, then I would suggest maybe you're not playing enough video games that have the map in it, the questing map video. I don't play a lot of video games. I'm not good with directions myself, but I did play Zelda back on the old Nintendo unit, and that helped me at least enough to say, no, I'm not going to make another map quest to show me how to go from my home to the school, just because yesterday when I made the map quest, I made that when I started home and went to school, and today I'm starting from my friend's house, but I'm not going from my friend's house directly to school. I'm going from my friend's house to home, and then the home to the school. So I already have the distance between these two nodes. I don't need to map it out again. I'm just going to say, okay, I already got that. Once I'm home, I've got my map quest. I'm going to go from there to there. So as we can see, the arrangement is different from what I did from day to day. I'm at the friend's house, and then I go home, and then I go to the school, and then maybe back to the friend's house, and then home, right? But the distance from going from home to the school is still the 7 miles. 7 miles to go from this point to that point. 7 miles to go from this point to that point. Next question. What if I want to rename the system, give them numbers? Because maybe my friend has this funny Greek name. It's like an ancient Greek name that they got from the Iliad or something. And I don't speak ancient Greek. So what I'm going to do is I'm just going to give you a number. It seems impersonal. That's not nice to do. I'll try to get your name better later. I'll remember it later. I'll work on it. But for right now, you're just a number, okay? Because I can't speak ancient Greek. All right, so I give it a number. So now home is number 1, school is number 2, and friends is number 3. So home is number 1, school's number 2, friends is number 3. I plug those into my database program, into my sorting unit, so I can see the distances from each of these locations to each of the other locations. Question, do I keep the same number for the same locations here as I do it in a different order, or do I renumber the system for 1, 2, 3 this way, or do I do it this way? Do I keep the same numbering system? Home is still 1, school is still 2, friend is still 3. Or do I say, well, no, I started at my friend's house, so my friend's house should now be number 1, and the home should be number 2, and the school should be number 3. Generally, we would say no, we want to keep the same numbering system, because that numbering system is the name of the node, the specific place on the map that we want to basically keep the same. And if I do that, then it allows me to say, well, anytime I'm going from one node to the other node, I already have the mental framework in my mind. So if I'm going from home to school, then I know what that is, right? Home to school, I always know what the distance is. All right, so that's the key. That's the key to understanding and mapping out a game. We learn all of the nodes in the game, and I might go to all of these nodes in different orders, but I know that if I'm going from point 1 to point 2 or point 1 to point 3, that I know how to get there, because I can visualize the map, and I've labeled those points either by name or by number, and I know then the relationship between each of them. That's how you master the game. That's how you master a map. That's how you master the fretboard, which is a map of our game. All right, let's add one more dimension. Let's say that now we're at some point in space, and we're looking at these 3 locations, home, friend's house, school, on the planet. But the planet is spinning around. So it's actually changing location from my perspective out here in space. From out here in space, it's changing. Let's imagine that I'm just going to give it 12 spots as the world is spinning around in a circle. So obviously from my perspective, I'm going to want to name those 12 spots as something different, because now I'm looking at it from a different perspective. But once I'm into these nodes, do I want to rename the nodes? No, I want to keep them the same. Why? Because the distance between all of these 3 nodes is still the same once I go into that area, into that space, and look at the distance here. It's only different from my perspective as the world is changing up top. And that, of course, is analogous to moving up and down the fretboard, playing in the 12 different keys. Let's take that idea to the fretboard. So the fretboard is a map. And it really is just a map. It's nothing different than playing a video game where you have not 3, but 7 different points, 7 different locations on the fretboard, right? They're different nodes on the fretboard. That's all it is. They're physical nodes. They represent fixed places in sound as well, because they represent relationships or changes, distances between those. So if I just pick up 3 of these, let's say I named these 3 points on the fretboard, and let's say we gave it the numbering system of 1, 3, 5, or a naming convention of I, P, and X, then if I go from my home to the school to the friend's house, then I might number it 1, 3, 5. What if I start at the friend's house and then I go home to the school? Once again, do I want to rename the nodes in the system? No, I don't want to rename the nodes. I'm still going to call this whatever numbering system X. It's going to be my friend's house, and then I'm going to go to the home, and the distance from the home to the school is the same. So this would be analogous to us naming 7 points within the system. When I name 7 points within the system, do I want to use scale degrees and rename them? Do I want to rename this 1, 3, 5, and then when I start here, name this 1, 3, 5? No, I want to keep the naming convention the same because my goal is to look at all the nodes within the system and be able to find directionality, distance between all the nodes. That's how you master the fretboard. It's just like mastering a map, and the naming convention, if we rename it, will throw us off. Now, let's add the other dimension. Let's imagine we're adding the dimension where these 3 points are going around the globe and we're in space and we're looking at it. So now there's 12 different spaces that we've cut it into that as it moves around the globe. Well, that just means that it's going to shift up, right? So now it's been moved up here from my perspective, but now when I look at it, when I go into it, the 3 relative positions are the same. So what do I want to do here? This would be like changing keys between the 12 keys. So this would be going from the key of C to the key of D. So now I'm looking at this note, and I'm going to say, well, now that is my center point, and I'm still going to name the 3 places: home, school, friend's house. It's still the same relationship. The distance between them is still the same. This would be analogous to the question of what's more efficient: naming all of the notes on the fretboard by note, which would be useful to do to know that you're on D, but it's more efficient to then say, I know this is my home base, and I want to give the relative positions, meaning the relative to the modes or the nodal points. So I don't really want to. It's not as helpful to see that that's a D per se when I'm playing within that key. It's as helpful to say within this shifted up position, that is the 1. This is the 3. This is the 5. This is home. This is the school, and this is the friend's house. Now, when I say home, you might think of it as tonic, right? So you might be thinking tonic, and what if I make this the tonic? I don't mean home like that's where I spend the most time. That's just what the node is called. So I might start over here and make that the tonic, meaning that's where I spend most of my time, at the friend's house. I don't like my house for whatever reason. It's, there's a lot of noise going on there. People, it's crazy stuff happening. So I'm going to go over to my friend's house. That's where I spend my time. So I'm still going to call it my friend's house. I'm still going to call it number 5. And even though that's where I spend my time, and then the home is going to be, 1 and 3. That's going to be the idea. All right, keep that analogy in mind as we think through this. So the traditional system limitations uses scale degrees relative to a key or tonic. So the result, you relabel every scale when shifting the tonic. So let's look at this practically. And again, I'm looking at this from a practical standpoint, and I think it's objectively just obvious that when you're learning the fretboard, that's not the way you would want to do it. Now, again, you could say, well, if I'm writing sheet music or something like that, I have to conform with sheet music or whatever. And so there, and again, there could be systems like that. That could be a reason. But again, I think most of that, even all the way down the line, you could build everything out more efficiently, right, if you did it in a system like this, right? So the only reason we are doing the current system we are in is because that's the way it's kind of been built up. So I just want to point that out because that's going to make it a lot easier for you to learn the fretboard efficiently and bridge for communication if you're doing sheet music and or whatever you're doing. All right. So let's say we have the modes. Now let's say we have 7 locations, right? So what are we going to do? We're going to name I. That's going to be like our home. I is home, and then we have the friend's house. So if I stay home, what's going to happen? I'm going to go from this node to this node. I didn't go anywhere. I went from I to I. right? Or if I go to my friend's house, what can I do? I'm going to go from I to D. If I give them a numbering system, I'm going to go from number 1 to number 2. All right. Now, if there's more locations like the school, I'm going from number 1 to number 3, which I'm going to call I for home. P is location 3. 1 to 4, I to Y. 1 to 5, 1 to 6, 1 to 7. So if there's 7 locations instead of 3 locations, then what are all the locations I can go to from this node on the map from home? Well, I can either go 1, 2, 1, 3, 1, 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, or I, ID, IP, IY, IX, IA, and IN, right? And then, well, what if I start at the friend's house? We're going to call that Dorian. So friend's house is Dory over here. Start at Dorian. Well, now I'm going to, if I stay there and we don't go anywhere from that location, I would be going from D to D. Or I would say location 2, that we called it, to location 2. No distance change. We're staying at that location. Or we can go from D, the friend's house, to the school, let's say, right? That would be going from 2 to 3. Or I can go from 2 to 4. I can go from 2 to 5, 2 to 6, 2 to 7, or 2 to 1, meaning back to the home. I'm not saying home as tonic. That's just one location, one node within the system. In this case, this is the main place. I'm at my friend's house more than home. So from a tonal center point, it would be the friend's house, right? This would make sense. This is the logical way to do it. What do we normally do? We kind of think of like Ionian as our starting point, and then we number the system as you would think. But when we go to the Dorian, what do? We're at location 2, but I renumbered the system. So instead of keeping it number 2, I'm now calling it scale degree 1 of the Dorian. What does that lead to from a numbering system? Well, now if I stay there, I'm going from scale degree 1 to scale degree 1. I'm at home 2, but I'm calling it 1, 1 from my system, right? Which makes a problem because I would like 1, 1 to be home, home, not 1, 1 to be my friend's house to my friend's house. So now 1, 1 was I, home, home. Now 1, 1 is DD, friend's house, right? And now I've got the 2, 1 would be if the second scale degree is now going to be 1, 2, which stands for Dorian to P, like the school. Whereas it was the 2, 1 stood for Ionian or home to 2, right? ID. So see, the numbering system is off now. So by renaming the scale, every time I start from a different location, every time I spend the night at home versus every time I spend the night at my friend's house to wherever I start at, I'm renumbering that as the 1, giving all of the nodes within my map a new name. That would be like if every time I'm traveling around the Zelda world and I spend the night at a different spot, I'm going to renumber all the locations at whatever spot I wake up at whatever spot I'm starting from. See how that's a problem? I don't want to do that. I want to keep the numbering system for all the locations the same so that I can have one map from each location to each of the other locations. That's the objective from a practical standpoint. All right, what's the other problem is off by 1 confusion. The first degree of the scale is labeled 1, causing misleading results when counting distances. So analogy, so this when we rename a system, notice if you're a computer coder or just a normal measurement, you don't rename the unit that you're on as 1 of the system. You're going to get an off by 1 problem. So analogy, you have this kid, right? And the basketball hoop. The basketball hoop is the 10-foot high basketball hoop. Let's say the kid is 3 feet. He looks bigger. He's not right under the hoop right now. But let's say you're measuring from the top of the kid to the basketball hoop. How far is that distance? Well, you can say, well, of that system, his head is going to be unit 1, right? That's the first degree of my system. And then it's going to be going up 8 feet. With head 1, it's the 8th foot up, right? But that's not how you would normally do it, right? That you're going to be off by 1 if you do that, because you shouldn't start at 1. You should start at 0. His head is 0.0. I don't need to rename it. We're going to start from above his head and say from above his head, there's a distance of we'll imagine 7 feet, right? So if he was 3 feet, there's a distance of 7 feet above his head. The current system is labeled to rename the first point that you're on, which means that you're always off by 1 from a distance. All right, let me explain this. So this is how you would normally think of it, right? Let's say you're home again, and I can either go to 7 different locations. Home to II, ID, IP, IY, IX, IA, IN. Now there's 2 different units of measure. We have a 7 scale. We have 7 notes in our scale, which represents 12 notes in the actual musical alphabet. So we actually have 2 sets of ways that we can measure, either by scale degrees, which I would call the modal half steps. I'm calling them because we call each of these nodes a mode. And then we have actual half steps, which are like our baseline unit, miles. So let's say we're going from eye to eye, home to home, is a distance of 0, whether you're talking about modal half steps or actual half steps, notes. If I go from I to D, my house to the friend's house, we're going to say how far is that? We can say it's going from 1 to 2, or let's say it's going 1 modal half step. It's going from one to the next unit within our system. And if in terms of actual distance, like miles, we're going to imagine it's actually 2 miles. Now notice you could go clockwise or you could go counterclockwise in our system around the block. So if there's 7 units, we could go distance-wise the other direction, -6. -6 and 1 is 7, right? I could go the other direction. There's 12 units from a half step standpoint, 2 in one direction, 10 in the other. Let's say we're going to the next unit down. We're going from I to P. Well, in our system, there's only 7 units, and we're going to say like they're in order. So that means that means that I'm going to go 2 modal half steps up, 2 locations up on my 7 location system, right? In terms of actual miles, or in our case, notes, we're going to say that's 4 notes away. I can go around the block the other way, which means 2 minus 7 is 5, or around the block the other way, 12 minus 4 is 8, right? So that's going to be our system. This is the distances that we could have. If I go then to the Dorian, now I'm starting at my friend's house. We're starting at D, unit D. If I stay there, D to D, that would be placed location 2 to location 2. I didn't travel anywhere, right? But if I start at location 2 and then I go to P, the next location in our system, now we've gone 1 location up. All the locations are in order around the block in our system. So now we've gone 1, what I would call modal half step up, 1 node up in the system, which in terms of miles, analogous to miles, which are actual the distance in notes, 2 nodes up, which if it's 1 node up, it would be 6 nodes if I went around the block the other way. If it's 2 miles or notes up, 12 miles in total, it'd be 10 the other way. What if I go from D to Y? So now I'm starting at node 2 and to node 4. So that means I went 2 nodes up from that node. See, I don't have to renumber the node that I'm on. I'm measuring from the node around the nodes in the circular system. It's 2 nodes up, which has an actual distance in equivalent to miles of 5. If I go around the block the other way, it would be 5 nodes going around the block the other way, which would have a distance of 12 minus 3 or 9. This is how you would normally map out the system, right? But this is how we actually map out the system. Ionian kind of matches what we're doing up here, but our distance measurements are now these. We'll get into these later, but we call it a perfect first, a major second, a major third, a perfect fourth. Now notice that these are called intervals, which we'll talk more about later, but they don't give me the actual steps in equivalent to miles, in essence, the notes. We have to just know the distance. We have to just memorize that a perfect first is 0 distance. A major second is 2 in terms of notes. A major third is 4 units, right? So what does this 3 stand for? The 3 stands for the scale degree. So we numbered the system 1 through 7. There's 7 locations in the system. We numbered them 1 through 7, and we said this is the 3rd scale degree. Now, this is where the problem is, because I wouldn't want to call it the 3rd scale degree. What I'd want to say is I started on this node. That's the point I'm on, 0 to 0. I didn't travel anywhere. So I'd like to say, no, this isn't the third scale degree. It's 2 units up. It's 2 modes up. It's 2 nodes up in the system. It's 2 locations up around the block. And that's where we get the off by 1 situation. So if I go to the Dorian, notice what happens is now they rename it. So now I'm at my friend's house and we name that the 1 because that's where we're spending most of our time. And so now we've renamed it as the 1. And so you end up with that different naming convention we saw before. And you also end up with the distance conventions being the same. So now we have the 1 relative position is a perfect first. This now is the major second, stands for the second scale degree. The minor third stands for the third scale degree. But now this minor third, I have to know that because it's a minor third, that means it's an actual distance in notes of 3, rather than a major third, which is a distance in notes of 4. So that's how. So we'll get into those scale degrees later. I just want to point out now that this 3 still represents the third position, and what's happening is they feel like with the scale degree system that we have to rename the point that we're on the 1 in order to do that. But you could do the whole thing without doing that by just saying that's the node that we are on, and I'm going around the block to 2 nodes up. So this would still be 2 nodes up. So notice that so the point is that all of these numbers and the scale degrees you can think of as off by 1 from a true distance perspective. In other words, they should be in what I would call modal half steps. All these scale degrees are up by 1. The perfect first should be a distance of 0. It should be the 0th modal half step, which is the scale degree of 1. This 2 should be the first modal half step away, which leads to a scale degree of 2 if you make the point you started at the 1, right? This 3 should really be the second modal half step away around the block from that node, which gives you to the scale degree, if you make it the 1, it's off by 1, the third. This 4 should really be the third modal half step from whatever the starting point is, which would get you to the scale degree of 4. This 5 should really be the fourth modal half step up from the node as you go around the block from whatever node you're starting on. In this case, node number 2 should be the 4 that you go around, which would give you the fourth modal half step, which would give you the 5th scale degree. This 6 should be the 5th modal half step, which would give you the scale degree of 6. This 7 should be the 6th modal half step, which should give you the scale degree of 7. So I hope you can, so my point is, you can do the whole system, you can compare everything together, you can still line up all of the intervals and compare them through all the 7 different locations without renaming the system. Okay, so my point is the whole thing works better if you use this system. The only reason we don't use that system is conventionally that's not how it got developed. But if you do this, you don't have to renumber the fretboard, and that's way easier. And you can see the bridge is really easier to get to the naming convention because it's off by 1. These are all too high by 1. From a normal measuring standpoint, they're all too high by 1. All right, the modal naming solution. So modes are fixed and cyclical. You got Ionian, Dorian, Phrygian, Lydian, Mixolydian, Aeolian, Locrian. Those names are the problem. That's why we can give it a numbering system. We'd like to keep the numbering system, however, an absolute modal numbering system. So assign each mode a consistent letter or number. So we could give them an abbreviation. I chose IDPYXAN. I'll talk more about that when we get to the practice problem, why I chose those letters, but those are those, or you can give them a number, 1 through 7. Benefit: the position of modes doesn't change when shifting tonic. Your thinking stays locked into the modal logic. That's what you want to do. You're memorizing the map of the fretboard. Don't change the locations of the map when you're trying to memorize the map. The distances are all the same from one point to another. So what are the modal ranges? Modal range, the number of modal steps from one node to another. Now, I call that a modal range because we're thinking about, you can think of the units in the system, either a 7-note scale system or the 12 notes. They're all in order, which you can think of them linearly, but they also repeat octavely. So you can think about going around a block. The point is that they're all in order. So that means if you label the range, if you say, I'm going to go from the second point to the sixth point, then those are the ends, the two distances, those are the ends. And the distance is the difference between the end point and the beginning point. Those are how many nodes up you went within the system. So if you label the range, that allows you to say, okay, how far is it? You take the end point minus the starting point, right? If I went from 2 to 6, 6 minus 2, that's going to give you the distance. Or you could have gone around the block the other way, right? Because you could have gone around. So that allows you to then quickly see what's the distance going forward, what's the distance going backwards, which is another problem with the current calculation for distance. We only say going one way. We say the inverse going the other way. We'd like to have directionality going both ways, forward and back. You can count both clockwise and counterclockwise on the modal wheel. So it introduces modal half steps. So this is my term, modal half steps. Again, we don't really see that, but note that if you have a 7-note system out of the 12 notes and they're always in order, then it would make sense to number the 7 notes just like you would with a clock kind of scenario. And think of the modal half steps, the distance of the 7 nodes, the 7 points on the block that you're going around in a circle around. You can name them and call them modal half steps, which is the 1 unit, and modal whole steps, that's how you make a chord. You take every other note within the 7-note system of all the points around the block that you're going to. That's how you make chord, modal whole steps. All right. So that's going to be the idea then. So now we're basically back to our fretboard here. We can name our system. Hopefully this makes sense. You want to name all the points on the fretboard. You want to name all the points in a name that doesn't change. So that means I'm not going to renumber each of the points on the fretboard, no matter which of these places I spend most of my time in. If I'm spending most of my time at home, then I'm not going to change the numbering system just because I'm spending most of my time at my friend's house over here. Or just because that's the place I started at. I'm not going to change the numbering system, right? I'm going to just call that the tonic. That's where I'm spending most of my time. But I'm not going to change the location name. And when I shift up, I'm not going to change the location name. I'm just going to change my perspective on where all those are located, just like my place on the planet. As the planet shifts around, I'm not going to call the location of Europe a different location because the planet is spinning and I happen to be in space looking at it. No, it's the same location. I'm just going to change the degree of my angle of vision as it rotates. So objective benefits. Consistency. Modal ranges do not change as the tonic shifts. Efficient visualization, especially helpful for instruments like guitar, where the fretboard is patterned. It's similar to most instruments, including the piano, although the piano does have differences because it's not completely symmetrical, but the concepts still apply. Reduced redundancy. You don't have to rename modes or intervals with every key change. That's the point. When you go from any key, all the relative positions should have the same name. When I play in any mode within the same diatonic shape, all the points are the same. The goal is to remember all of the distances between all of the points on the map. Don't rename the map. Mathematical clarity. So the modal half steps and the note half steps make stepwise progression easy to quantify. So clearly, if you only have 12 notes around the block, and you only have 7 notes around the block that are the places that you actually stop at around the block, it'd be great to number them because then you could do simple math. I mean, it's mind-boggling that we don't do that, right? We should number. You do simple math and say, well, this is how many modal half steps we went distance-wise in terms of the 7 units that we travel, which you can easily do if you just give them a permanent number. So why hasn't this been done? Well, historical lock-in. The system was developed around the keyboard, instrument, and church modes. I'm not going to say, once again, that the keyboard shouldn't be holding us back because I think people that learn on the keyboard have a great advantage in some ways because the keyboard's a great instrument, but they also have a disadvantage because the structure of the keyboard is going to force you to think the way the keyboard is structured with the white keys being the key of C somehow being more important, and the sharps and flats do look like they're less important. And so you have to kind of unlearn that from like a theory standpoint, I would think. So in some ways, like I learned just basically on a guitar, I think in some ways I didn't have to, that was beneficial in some ways and harder in other ways. Obviously the piano is way more flexible to play and you got two hands and everything. So I'd love to know how to play the piano better. I mean, but it is what it is. Key of C bias, built from C major, then altered with sharps and flats. So once again, it leads us to think that the key of C is kind of like the main key. And if we number the key of C, I guess the idea was that they wanted to then use the same numbering system. So they made an off by one from a coding standpoint system because it's natural to do that. By the way, I'm not saying like, well, they're stupid. No, everybody does that. Human beings number from 1, not from 0. But you can see what they're trying to do is they're measuring distance. We're trying to measure distance. And in that case, we usually measure from the point, the node. And instead of doing that, we renumbered every system from 1 instead of from 0. Okay. Lack of digital conversion. Until recently, printed theory made it difficult to dynamically translate the system. Now you might say, if I learn a system like this, if I use a different naming convention and whatnot and write it, then that's going to cause a problem because I won't be able to convert it. Now I want to say that functionally you can, because the current system is always off by 1. Just know that so that when you play, it doesn't throw you off. You know what the distances mean. You know it's off by 1. You can accommodate for it. If you write things down and you prefer to write it in a way that I think is more clean, the cleaner system, I believe, then it's easy to convert because now even ChatGTP, once again, ChatGTP, you could just say, hey, look, I'm doing it this way, ChatGTP. This is my numbering system. 1 through 7 is always 1 unit less than the system. And now just map it out, just convert it. Like you don't even need specialized software. So that's the key. That's why these days, there's less and less reason not to think of things more efficiently, because even if you write in the more efficient way, you can convert. Even if you're reading something in the way that's not as convenient for you, you can convert it. The conversion is easy. So why not? And by the way, you can see this in the Nashville music system, right? The Nashville music system, what are they doing? They're basically saying, I'm going to take the song in whatever key it is, and I'm going to convert it to the key of C, so that I can keep the numbering system the same, right? That's kind of what's happening. So obviously that's easy to do these days because the software can do that. You can just say, hey, ChatGTP, write this song, give me the chords in relation to the key of C. So even though it's in A minor, it gives me, the key of the major scale, let's say. So if it was in the related A minor, then just write it as though it's in the major so that A minor shows up as a 6 chord, right, instead of a 1. So it's all the same. And so all we would need to do is recognize. I'd like to take one more step and say I still want to recognize it's in A minor. I just want to keep the numbering system the same, so we could do it. So spreadsheets like Excel allow flexible modal logic mapping. So obviously Excel hugely useful to kind of map this stuff out logically. The internet enables on-the-fly conversion and real-time exploration. So it's just like if you had something in Spanish, you plug it into the conversion. It's even easier to plug it into the conversion because Spanish, that language, every language is more complicated to convert. The conjugations are different and everything. The spelling's different. But when you look at this logical system, it's just a logical system. Everything works perfectly. It's perfectly convertible, easy, right? Not for me, but for like ChatGTP or something. Players want practical system to support improvisation, and learning. So clearly, from a guitar standpoint in particular, that's useful. Notice that a lot of times people confuse like writing stuff with sheet music. Sheet music was written for a very detailed, a composer that's writing exactly what you want them to do. Whereas a lot of guitar players just write the chords and the progressions because they want to get the general idea and then they want to improvise within that concept, whatever that concept is. So if that is your goal, that's why tablature came about. That's why we write in like just chords and whatnot. So if that's the goal, what we would like to do is come up with a nice, easy system that is as clean as possible, right? So if there's a cleaner way to do it, then that would be worth doing. So modal ranges, so you got the modal half steps, the note half step, resolve core inefficiencies in traditional theory. They offer a scalable, elegant solution suited for modern instruments. So as more musicians adopt digital tools, this system can become a newer standard. So I really think that, now that we have ChatGTP, like I say, take what I'm saying here, copy the transcript. You probably have access to the transcript. Copy it, plug it into ChatGTP or whatever your favorite AI tool is, and check it. Say, ChatGTP, does this make sense? It's a logical system. ChatGTP should be able to tell you, does that make sense? If you were to make the thing today, would you make it differently? And then why? And if that's the case, and everybody has the ability to jump on ChatGTP or whatever to make the conversion and see the argument, then I would think that at some point we're gonna move towards what's the easiest thing to do, even though it's been written down before. Like we're getting past the point where like it was like everything was vocal. We were in a society where everything was word of mouth, and then everything got written down on the page, which made everything static once written down. And now we're getting to a stage where we're getting more to the verbal again, because now you can work with the computer and actually talk to the computer. You don't even need text so much, which might open up things to be able to change again, which more fluidly, which might be good for certain things like writing standards or speech standards, which are not optimal. They just happen to be what was frozen in time when they were written down. I don't know. That's just my theory. So we're going to go over some more of this stuff in our Excel worksheets, though. So we'll talk about conversion tables between scale degrees and modal ranges, summary of tonal distances for each modal interval, and visual fretboard layouts. So we'll map it out. I'll map it out as systematically as I can, and we'll work it through the Excel.